Assalamualaikum warahmatullahi wabarakatuh. So this is our last theoretical meeting in this semester for airport design class, and today we will going to discuss about the pavement design part 3. This semester we will learn about 3 methods in flexible pavement design. First, there is FAA method from US that we already learned about it before, and the second is the PCN method. This is from ICAO, which actually this is a single standardized method of reporting pavement strength that we already learned about it before in our last meeting. And for the last is LCN method. And now we will talk about the LCN method, or load classification number. Now we will talk about LCN method, or load classification number. For this meeting, the source is from the documents from Defense Estates Ministry of Defense from UK in the document entitled Design and Maintenance Guide number 27. So for a comprehensive explanation you can see this document. So what is LCN, or load classification number? So LCN is a number expressing the relative effect of an aircraft on a pavement, or the bearing strength of a pavement. So basically this is not a design method, LCN is, but the LCN is like the PCN. So the LCN is just express the relative effect of an aircraft on a pavement, or we can say it as a bearing strength of a pavement. So LCN is not a design method. And the original LCN classification system was developed in UK, of course, in the late 1940s, but in 1971 the method of calculating LCNs was altered and the LCN or LCG system introduced. So later we will talk about the LCG, or the load classification group. So this is about the introduction about the LCN. So for the LCN history, in 1948 UK published a load classification system which called by the LCN, or load classification number. And the LCN represents the relative damaging effect of wheel loads and tire pressures of aircraft. So all of the classification here is based on the wheel loads of an aircraft and the tire pressures of the aircraft. And the LCN will represent in a scale ranging from 1 to 100. And in 1959 the department published document entitled Airfield Design and Evaluation, and this document including design charts for rigid and flexible pavement, which use LCN as the parameter for aircraft loading, of course. And also there are charts for the design of overlays on existing pavements. And in 1971 they published the document entitled The Design and Evaluation of Aircraft, which introduced the concept of LCG. So LCG is the load classification groups. So the LCG is categorized aircraft LCN value into 7 groups. And in 1977, the ICAO Aerodrome Design Manual mentioned LCN system as one of the recommended methods for reporting pavement strength. But unfortunately, it didn't become popular outside UK. Why? The reason that LCN system is not popular outside UK because the LCGs, or the load classification groups, which categorize aircraft LCN values into 7 groups, embrace too wide range for practical use. And also because there is a new LCNs, so the new LCNs were often confused with the previous LCN values. So this is why the LCN method is not become popular outside UK. And in 1989, the guide was the move from the previous LCN-LCG classification system to the ICAO aircraft classification number, pavement classification number, or ICAO ACN-PCN. So because there are so many pavement reporting system, so the ICAO decided to make a single universal method for reporting the pavement, which we already talked and learned about this. This is the ACN-PCN method from ICAO. So why ICAO formulate a single universally accepted method of classification in reporting pavement? So this is basically for safety reason and the efficiency in the airfield pavement, and the ICAO ACN-PCN method will first enable aircraft operators to determine the permissible operating weight for their aircraft. The second is assist aircraft manufacturers to ensure compatibility between airfield pavement and the aircraft under development. And the last is permits airport authorities to report on the aircraft they can accept and follow them to use an evaluation procedure of their choice. So this is why basically ICAO developed the ACN-PCN method. And for the ACN-PCN method, we already talked and learned in our last meeting. So I will not explain more to you in this meeting about the ACN-PCN method. So this is the table for LCN system, and this is the table for LCG system. And for the LCN system, the LCN number, like you can see here, this is basically from 1, but for instance the table is from 10 to 100. So this is the LCN value or LCN number. The LCN number is based on the wheel loading, like I actually said before, from wheel loading and the tire pressure. This is in pounds and this is in kilograms, and this is the tire pressure. So basically this table is from these charts here. So these charts, you can see this is for the equivalent single wheel load. So the wheel loading here, we just put it in here. If we want to know the LCN value or the LCN number, so this is the graph for LCN value. here. So as you can see, this is 120, 115, 110, 105, and this is 195, 90, 85, and etc. here until 1. And so this is the LCN graph, and this is for the equivalent single wheel load or for the loading, and this is for the tire pressure here. So if we want to look for the LCN value or LCN number, we should have to know first the wheel loading or the equivalent single wheel load here. So for example, if we have the equivalent single wheel load here, then we project it horizontally here, and then this is for the tire pressure here, and we will project it vertically. So we should have to make sure that this two lines is perpendicular here. Then after the two line here is met, we can read the graph for the LCN here, in which curve these two line is met here, and then we will know the LCN. But if for instance from this graphic, we'll convert it to the table here, so we can see from this table also. And for the LCG or the load classification group, which divided the LCN range into 7 groups. So this is for the LCG1. So for the LCN range from 101 to 120, and for the LCG2 is for the LCN range from 76 until 100, and this is for the LCG3 for the LCN range from 51 to 75, and etc. So this is the LCG or the load classification group. So this is the charts before. This is the same one, and this is if we want to decide how thick the pavement is, we can use this chart. So after we know the LCN number or the LCN value based on the equivalent single wheel load and the tire pressure, we use these charts. So these charts require the CBR. So this is the CBR, and this is the LCN, which we already know from these charts. So we just project it vertically from the CBR until we met the curve from the LCN here, and then we just project it horizontally until we know the thickness of the pavement here in inch. So here is the example to determine the thickness of flexible pavement with LCN method. So the question is, determine the thickness of the flexible pavement from the data below. So for the equivalent single wheel load is 42,000, and for the tire pressure is 150, and then for the CBR subgrade is 5 for the CBR subbase is 20, and for the CBR base course is 50. So how we will determine the thickness of the flexible pavement? So first of all, we will use these charts. So with these charts, we should have to put the equivalent single wheel load number here. So from the question, we already know the ESWL is 42,000. So we will just plot it here, around here, because this is in 1,000. So we just plot it in the 42 here, and then we project it horizontally, and then from this side we will project it vertically from the number of tire pressure. From the question we know that the tire pressure is 150, so this is 150, and we project it vertically until we met this one, that we project it horizontally. Then in this point we should have to read the LCN number. So because it is in the curve of LCN number 50 here, so we already know that the LCN number for the ESWL 42,000, and for the tire pressure 150 is 50. The LCN number is 50 here. So the LCN number is 50. Then we should have to calculate the total pavement thickness from this chart. So this is the second chart. So we will just plot the CBR here. So from the data here, we will use the CBR subgrade. So for the CBR subgrade is 5. So we will plot this 5, project it vertically until we met the curve for LCN 50 here. So this is the LCN 50, the curve for LCN 50. So after that we project it horizontally until we met the total pavement thickness here. So this is around 32 inch here. So the 32 inch is the total pavement thickness. It's not the subgrade pavement thickness, but this is for the total pavement thickness. And then we calculate the subbase thickness. The LCN we use here is the same. So for the LCN here, all of this LCN is the same, which is 50. And the different thing is the CBR here. So the CBR for the subbase thickness, we will use the CBR for the subbase, which is 20 here. So we just plot it here, 20, and then project it vertically until we met the curve for 50. The LCN is 50 here, and then we project it horizontally until we met the subbase, until we met the thickness, but this is not the subbase thickness. So from this chart we can read the thickness is 15. So this is so this is from the chart we know 15 inch, but for the subbase thickness we should have to subtract 15 from 32, or the total pavement thickness. So 32 minus 15, we will get 17 inch as the subbase thickness. So this is not the subbase thickness, but the subbase thickness we should have to subtract here this from the total pavement thickness here. And then let's calculate for the base course thickness for LCN 50 and the CBR 50 from here, CBR base. So this is 50, and then we project it vertically until we met the curve for LCN 50, and then we project it horizontally until we met this. So this is around 8 inch. So this is the 8 inch is not the base course thickness, but we should have to subtract 8 from 15. 15 we get it from here, and then 15 minus 8 is 7 inch. So the base course thickness is 7 inch. And for the conclusion, the surface thickness is 32 from the total pavement thickness minus 7 for the base course thickness minus 17 for the subbase course thickness. So for the surface thickness is 8 inch, for the base course thickness is 7 inch, for the subbase course thickness is 17 inch, and the total pavement thickness 8 plus 7 plus 17 is 32 inch. So this is how we use the how we use LCN method to determine the thickness of the flexible pavement here. So we already know about the LCN and LCG system of reporting pavement, but in the beginning of the slide I already talked to you that nowadays, internationally or globally, the airport classification pavement number is based on the ACN-PCN method, or exactly the PCN method. So sometimes we should have to convert the LCN to the PCN. So actually there is no direct equivalence between LCN and PCN, and any method of conversion can only be approximate, and for the conversion of LCN to PCN we will use figure 42 and figure 43 to equating pavement using LCN system to the PCN system. So this is the figure for conversion the LCN to PCN. So this is the LCN number. So if we have the LCN number or value, we just can plot it here, and then we project it vertically until we met the curve from that based on the K here, and then after we met the right K, the right number of K here, we just project it horizontally, and then we will get the PCN number here. And this is for the rigid conversion. So how about the flexible? So this is for the flexible conversion from LCN to PCN, or etc. actually. So this is if we have the number of LCN, we just plot it here, and then we project it vertically until we met the curve of the CBR here, the right CBR, based on the soil characteristic here, and then after we met this curve, we will just project it horizontally until we know the value of the PCN here. So this is how we use the conversion graphs. Yeah, actually, first of all, you should have to decide what kind of the pavement is, the rigid or the flexible, because there are two type of the graphs, the rigid one or the flexible one. So make sure that you use the right charts. And the second is select the subgrade category. So for the rigid pavement, it's based on the K, and for the flexible pavement is based on the CBR. And then project a line up from the horizontal until it intersects the curve for the appropriate subgrade category, and then project it horizontally to the vertical axis from the intersection. So here, this is how to use the conversion graphs. For notes, if we want to make a conversion from LCN to PCN, there are some notes that you should have to warn. The first is for the tire pressure. So because in PCN there are about the tire pressure, so for this concept there need normally to be no tire pressure limit on concrete or martial asphalt surfacing. And for the method of evaluation, because in PCN we should have to know the method of evaluation, like U or T. So for the method of evaluation, described as TR, which means the technical method of evaluation. So here is the example how we convert the LCN number to the PCN system. So the question is, find the PCN of a flexible pavement runway with CBR 10% if LCN of the runway is 70. So first of all, you should have to make sure that you use the right charts. Is it for the flexible or the rigid pavement? And this is the charts for the flexible conversion, so we already use the right charts here. And then after that, we should have to know about the CBR. So the CBR is 10%, so we will use this curve here, and then we plot the LCN number that in the question it mentioned 70, so we just plot 70 here, then we project it vertically until we met the curve of CBR 10%. Then after we met the curve, we just project it horizontally until we know the PCN number here. So from these charts, we will know that the PCN number is around 52 here, because this is 55, so maybe this is 52. So the answer is for the LCN number 70. So in the PCN system is PCN 52 from this chart slash F, this is stand for the flexible pavement here, slash B. So B is for the medium strength of the subgrade with the CBR about 10% here, slash W, which means is no tire, no or unlimited tire pressure here, slash T, which means the method of the evaluation is from technical method here. So the answer is PCN 52 slash F slash B slash W slash T here.